Enterprise AI needs a strong front door. In this topic, we'll look at how API gateways and WAF controls authenticate users, validate requests, limit abuse, block web attacks, and protect expensive AI services before deeper threats reach the application. So far, we've built the internal security foundation: architecture mapping, risk prioritization, SSO, MFA, conditional access, least privilege, and secrets management. Now we move that control logic to the edge, where AI applications are reached through APIs and web traffic. The goal is controlled entry, not just connectivity. Identity, authorization, and risk decisions should be enforced before requests reach AI services. Next, we'll apply that perimeter mindset to API gateway and WAF controls. AI systems can turn ordinary API requests into high-impact actions. One call might start an LLM session, launch an agent workflow, query enterprise data, or consume real compute budget. That is why the gateway and WAF sit in front of the application stack. They authenticate, rate limit, inspect, and block suspicious traffic before it reaches models, orchestration, or data stores. They do not replace secure code or AI guardrails. They enforce the first boundary. Treat the API gateway as the authentication checkpoint for every AI API call. Requests may come from users, services, agents, or partners. The gateway extracts the credential and validates key details such as issuer, audience, signature, expiry, and session context. That may involve SSO, OAuth, OIDC, JWTs, mTLS, or signed service tokens. If anything is missing, malformed, expired, or replayed, the request is rejected immediately. Only trusted identities move forward to the backend or model-facing service. Authentication is only the start. The gateway also uses identity context, such as role, scope, tenant, and risk level, to decide where the request should go. Employees, admins, partners, and service workloads should not all land in the same place. Token claims must be checked against the API being called, especially the audience claim. That audience check helps prevent confused deputy attacks by confirming the token was intended for this specific API. Request validation is the first security gate before AI logic runs. Start with strict API schemas, so required fields, types, and unknown JSON properties are handled predictably. Then constrain the transport: methods, headers, content types, payload sizes, and upload formats. AI adds its own checks, including prompt length, model choice, max tokens, retrieval options, and tool parameters. The goal is simple: reject malformed or abusive requests early, and keep downstream application code smaller, safer, and easier to reason about. Quota management protects both the platform and the budget. The API gateway should enforce limits at the right identity level: user, tenant, API key, token, IP address, or service account. Use rate limits for steady traffic, burst limits for short spikes, and longer quotas to stop slow abuse. Different endpoints need different thresholds. Metadata calls may allow more volume, while model inference needs tighter controls. When blocking, return a clear 429 with retry guidance, not internal details. AI applications still face the classic web attacks that have targeted apps for years. A WAF provides a first line of defense by applying managed OWASP rules, normalizing requests, and blocking suspicious patterns like SQL injection, XSS, path traversal, file inclusion, command injection, and credential stuffing. Apply these protections across login, chat, upload, admin, and tool endpoints. Start in monitoring mode, tune false positives, then move to enforcement with confidence. Before traffic reaches the AI application, filter for signals that often indicate automation or abuse. Bot detection helps separate real browsers and approved crawlers from scraping tools, credential stuffers, and scripted prompt attacks. IP reputation adds another layer by blocking known proxies, scanners, botnets, and abusive networks. Geo-controls should be used selectively when risk, regulation, or business policy requires them. The strongest approach combines these network signals with identity, device posture, behavior, and rate limits. Managed rules catch common attacks, but AI apps also need rules tied to how the product actually works. Treat sensitive routes like chat, upload, tools, RAG query, and admin as special cases. For example, block oversized chat payloads, challenge low bot score clients, and restrict admin access by geography or identity. Add anomaly detection for unusual frequency, headers, user agents, and session behavior. Prefer allow listed methods, schemas, and origins, then keep tuning from telemetry and incidents. AI changes the abuse landscape at the edge. Attackers are not just sending bad HTTP requests anymore. They may flood prompts, automate jailbreak experiments, scrape outputs or embeddings, and intentionally trigger costly model calls. The edge becomes the first place to recognize these patterns before they drain capacity, expose data, or inflate spend. Rate limiting for AI should not treat every request the same. A short embedding call is very different from a long context agent that reads files and uses tools. Track tokens, requests, concurrency, retrieval calls, and compute time. Then apply quotas by user tier, tenant, and risk level. When usage rises, use graduated responses. Allow normal traffic, throttle bursts, queue work, challenge suspicious activity, downgrade models, or block requests before cost or abuse spirals. Here's what that looks like in practice. An automated client submits 5,000 jailbreak prompts in 10 minutes. The gateway sees rapid retries, repeated templates, and suspicious phrase patterns. The WAF adds bot and reputation signals. Application telemetry checks output volume, retrieval patterns, and session velocity for scraping behavior. Instead of blocking everyone, the system applies friction, such as proof of work, CAPTCHA alternatives, or step-up authentication. Suspicious prompt and session metadata then flows into guardrails and the SOC for investigation. A strong AI entry point treats every caller as untrusted until identity, intent, and policy are verified. Traffic should pass through WAF and API gateway controls before reaching AI services, with bot protection, rate limits, and threat detection applied consistently across public, partner, internal, and service interfaces. The stack also needs feedback. Secrets, SIM, observability, and cloud security telemetry should feed into policy as code, so blocked requests, throttling, cost spikes, and abuse signals continuously improve defenses. The big takeaway: protect AI entry points before traffic reaches your application or model. Use gateways for identity, token validation, routing, filtering, quotas, and throttling. Use WAF controls for bots, reputation, geo-rules, and anomalies. Then layer in AI-specific abuse detection, monitoring, secrets, and authorization as we move deeper.